So we were discussing about the IO request with respect to OS. We have taken the example of updating our operating system or any one of the softwares in your machine. So that is while updating, the provider may ask you the permission to write in your disk for the updation. And with respect to system processes, so during, for example, you are playing some music using VLC media player. So in between, you are done with the in between you're done with listening to consider 10 musics, 10 songs. So after that, you wanted to load again. So once, if you do not activate or if you do not enable the repetition, song repetition facility in your VLC media player, so then it may ask you, sometimes it may ask you to start with new playlist, or you may supposed to load the songs to the playlist. So in between, so the application itself generates a process saying that either you wanted to load a new one or you wanted to repeat it. That is how system process may work. So that is nothing but IO request. And then user processes. Consider you are preparing a PPT for your mini project. So once you done with that, that is preparation, you wanted to save that. So that save itself is the write operation on the disk. That is user processes. After finishing save operation, you may close it tomorrow, or after some time you may wanted to reopen it again. So reopening is the user process. Then coming to the IO request. So the request may include input or output, disk address, memory address, number of sectors to transfer. That is with respect to these three examples, we have seen all this. That is either our application updation or system process. In between, your system may need some processes or support from your machine, or user processes like saving a particular file or opening an existing file, right? And then to perform these many things, we may need a queue to have a continuous request. So that's why OS should maintain a queue of requests per disk or device. For example, if you wanted to print your report, your project report may have number of pages. You might have kept front page or cover page separately, certificate page separately, acknowledgement separately, content sheet separately, all these things. So you can give all these print command in a single shot. But in the backend, operating system will maintain a queue based on the size or based on the file name, starting from alphabetical order. That is how it works. Queue of requests can be maintained by the operating system. And sometimes we may have an idle disk. So you need not shut down your machine. You may keep your machine in the idle mode, or you may keep it in hibernate, or you may keep it in sleep mode. So once you come back, you may start on work with your IO request. Or sometimes if your operating system is updating, at that time you can't do any one of the tasks on your machine. So at that time you'll get busy disk. So you'll get a prompt, do not press any button on the on button, do not press any button. So that type of messages may appear, or wait for 5 minutes, then only you may switch on. So to do all these things, operating system need something like optimization algorithms, because to perform n number of requests, n number of processes, we need some mechanism. So we'll see all those mechanisms. We have number of algorithms for that one. We'll see one by one. Today we'll finish two algorithms. It's very easy. Just we'll go after it. So the first one, we have something called scheduling algorithms. Just consider this example. We have a sequence over here: 98, 183, 37, 122, 14, 24, 65, 67. So now these are the sectors. These are the sectors. What is a sector? A division or a block in a track. What is a track? With respect to platter, with respect to a disk, we have number of tracks like relay track. Each relay track will have number of sectors, number of blocks. So now consider these sequences as a number of blocks, sequence of blocks. Right now, our disk header pointer is in 53rd block. Our disk header is in 53rd block. So we'll see FCFS, first come first serve algorithm. So the queue, the pattern we have seen is a sequence 98, 183, 37, 128, and so on. So should start from 53rd. So you can see over here, please look after the cursor. So initial point is 53, then next 98, move to 98, then move to 183. So you move to 183. Then from 183, next is 37, come back to 37. Then 122, from here to 122, and so on. This is first come first service. So whichever the first sector or whichever the first block number we observe, we encounter, that should be visited first after the head. So we need two initial values here before beginning with the first FCFS algorithm. First one is header, from which point you want it to start. That is, in this particular example, it is 53. Then we should have a queue sequence. Then we can perform FCFS. So any clarification on this one? So only two things you're supposed to remember. One is the head, from where you wanted to start. Second one is queue, in what way we wanted to perform. This is works as a queue, first come first serve, or generally in general we may say queue is nothing but FIFO, first in first out, same thing, same manner. This is FCFS. Second one is SSTF. This is shortest seek time first. Same setup. SSTF, shortest seek time. We supposed to find out which is nearest to the position. That particular block will be read or written first. Consider same example. So we have same queue. Head automatically starts from 53. So now from 53, we supposed to find out which is the shortest. Now we have 37 on the queue, we have 14 on the queue, we have 65, we have 67. Now we supposed to find out which is nearest to the head. Head starts from 53. So the nearest is 65 that we supposed to encounter. So that particular block is visited. So then consider from 65, which is nearest? 65, then it is 67. Then from 67, which is nearest? So in this algorithm, once you visit that particular sector, you're supposed to forget that particular block. So we started from 53, forget about it. Then we found nearest to 53, that is 65. 65 is reached. Remove that 65 from the list. Then 67, that is the nearest. Remove 67. Then remaining, you're supposed to find out shortest seek time from the existing position. Something like shortest route, shortest distance. This is seek time. So 53 to 65, from 67, then 67 to the nearest is 37. Because we have the lesser value with 37 and 14 only. So out of these two, 37 is nearest. That's why we visited 37. From 37, the nearest point is 14. Visit that. So that also strike it out. Then we have 93, 183, 122, and 124. From 14, 98 is nearest. From 98, 122 is nearest. Then 124 nearest and 183. This is SSTF. So the difference is, coming back to FCFS, first come first serve. With respect to first come first serve, we started from header position. We already in the 53rd block. which is the first value we encounter, 98, automatically visit 98. Then the next value 183, we visit that one. Next 37, we will visit next one, 37. Next 122 in the index, visit that one, and so on. One by one in the queue we visit in first come first serve. With respect to SSTF, we will visit, we will find out which particular sector is having shortest seek time. The lesser value in this particular list will be visited first. So how to find out that lesser value? You're supposed to know where you're supposed to start, from which particular point you're supposed to start. So in this particular example, we started from 53. For this particular 53, 65 is nearest from the rest of the values. That's why we visited 65. 265, 67 is nearest, and so on. Any doubt in these two? Please raise your hand. Any doubt? No doubt? No doubt? Any doubt? Shall we proceed with another algorithm or shall we stop?
Enough, sir.
Enough. Huh?
Submission, sir, 4 o'clock.
What is it, Keith?
This is assignment submission.
Okay. Then we'll stop for the day. So that is enough. Please go through with the notes. Please go through with the notes. It is very easy and very easy to forget also. That's why. Important. That's all for the day. Thank you.
Thank you, sir.
So if you have any other doubt, you may ask.